This is the Unit 7 Algebra 1 test review. You will need a calculator at some point throughout this review, so you may want to have one handy. Number 1, predict if negative 3 squared will be positive or negative. Well, because the negative 3 does not have parentheses around it, that is going to be a negative 9. If it had looked like number 2, that's saying negative 3 times negative 3, which would be a positive 9. On number 3, we keep our base if we're going to use our exponent rule, so we keep our base of 2. We add our exponents, that is 2 to the 7th, and you can put that in your calculator if you have it beside you. Then on number 4, we can keep our base of negative 3. Probably be a good idea to go ahead and put that in parentheses. We can add our exponents, and we can have 2 plus 1 is 3 as our exponent. So if we were to evaluate that, that would end up being negative 27. On number 5, that's a power to a power. I have to apply in that 3 to the 3 squared, which means we keep our base and we multiply our exponent, so 3 to the 6th power. On number 6, first thing I notice is that 5 to the 0 power, that is just 1. So a couple of things. If you want to put a 1, that's fine. I usually just cross them out because I know anything times 1 is whatever the other thing is. Then I have to say, I have to bring down my negative, and then I can say 2 cubed is 8. And then number 7, I have to apply in this 2 to the 4 and the b squared. Notice I didn't apply it to the negative because that's outside the parentheses. So that is negative 4 squared, because your coefficients do not follow the same rules as your exponents, and then v to the 6th powers, because it's a power to a power, you multiply. And then if I simplify that, that's going to be negative 16 v squared. On number 8, I have to keep my base and add those exponents. So that's going to be s to the 5, and then plus 5 is 10th power. On number 9, you may be looking for an outside exponent, but there's not one. Those parentheses are just indicating multiplication. So I'm going to do 4 times negative 4 is negative 16. Then I have c cubed times c cubed. So I'm going to add those exponents and get c to the 6th. And then we have d squared that we don't have anything to multiply by, so we just bring it down. Number 10 is very similar, so I'm going to do it step by step. Negative 2 times 3 is negative 6. For the c, that's c to the 5th times c to the 4th, which is c to the 9th, because we add exponents when we're multiplying. And then finally, we just bring our d to the 6th down. Now on number 11, before we can multiply, we have to apply in this power of 2 to the second parentheses. And that should have only, make that look like it goes to the r, because that's where it goes, and then the s squared. So I'm going to bring over my negative 2r squared. Now, here I have an option, because since that's s to the 0, I know that's just a 1, and I really don't need to put that. And then the next one, when you're applying a power to a power, you're multiplying exponents, so that's going to be r squared, s to the 8th. Now it's just multiplication, so negative 2 times an understood 1, which is just negative 2. R squared times r squared is r to the 4th, because you add your exponents, and then s to the 8th. Number 12, I have to apply in twice, so I'm going to apply in this 2 to the 3, the q, and the r to the 4th. Remember that 3 squared is exactly what I just said. It is 3 squared, then q to the 2nd, r to the 8th. Then we're going to multiply that. If you want to put parentheses, that's fine. I'm just going to use a little dot. Then I have to apply in this 5 to the q and the r, q to the 5th, r to the 5th. And now I can multiply and put those together. So I have 3 cubed is just 9. And then for the q's, sorry, that kind of looks alike. And we add our exponents. 2 plus 5 is 7. And then for the r's, it's 8 plus 5 is 13. Number 13, I have to apply in this squared to the negative x squared. And a couple of different things to keep in mind. Really and truly, I'm going to redo my line because I need to apply that to the -1 and I need to apply that to the x squared. Now you can also think of it as if you have a negative number raised to an even exponent, you know that's going to be a positive answer. So if you treat it like that, you really don't have to take into account that you're saying -1 times -1, and which is just a +1, and then if I raise this x squared to the second power, that's going to be x to the fourth. Then we have, I'm going to bring down the negative x cubed. I'm going to use dots for multiplication. Now, same thing here with this squared. I know that negative x times negative x is going to be a positive x squared. Now I have a negative out front that I need to keep as part of my answer, and then I add the exponents. X to the 5 plus 4 is 9. And you don't have to put that 1, you can say negative x to the 9th power. On number 14, if you have a fraction multiplied by not a fraction, the easiest thing to do is to go ahead and make that a fraction and then multiply straight across the top and straight across the bottom. So that would be 36b to the third over 2. And then the only thing that needs to cancel is the 36 over 2, which would be 18b cubed. Then for number 15, I'm going to go step by step. I'm going to divide my numbers first. 36 divided by 9 is 4. Then we have x cubed over x, which is x squared. And then we don't have anything to divide with our y, so we just leave it and it stays on top. Number 16, we have to apply in the 8 to everything in the top and everything in the bottom. So that's going to be negative 4 in parentheses to the 8th power. That's important. And then q to the 8th power. And then you can put that in your calculator. I think it's 65,000 and something. But the most important thing to remember about that numerator is that it is going to be positive because it is a negative number raised to an even exponent. And then number 17, I have to apply in the 3 to the top, 3 to the bottom, just like we did in the denominator a while ago. You multiply exponents, so that's going to be s to the 6th over r to the 15th. Lastly, we need to find the area of a rectangle, so we need to multiply the length times the width. Now, one thing I would do before I start multiplying the length times the width is I would go ahead and simplify the top of this. So that's going to be 4 to the 4th power, a to the 8th power, and b to the 4th power. So that's going to be 256, a to the 8th, b to the 4th, and now I'm going to come over here and plug into that formula that I just mentioned, which would be 256, a to the 8th, b to the 4th, times 5ab squared. Now we're just multiplying, so that's going to be 256 times 5, which is 1280. And then we're going to add our exponents, which is a to the 9th and then b to the 6th. For number 19, I would plug in each of those answer choices for x and see which number came out the greatest. And I would honestly do this in my calculator. So A, if I plug in a 1, so I'm just going to write what my answer would be. That would be 1 over negative 2 squared. So the answer that I would get for that would be 1 over 4th. If I plug in b, that's going to be 2 over negative 2 squared, which would end up being negative 1 times negative 1, which is just 1. So I know 1 is larger than 1/4, so I know the answer is not A. Then if I check 0 for C, I would say 0 over negative 2 squared, which I know is just going to be 0. So I know 1 is still bigger than 0. And finally, if I check negative 4, so I'm checking D now. So I have negative 4 over negative 2 squared. So that actually makes a positive 2 squared. So if I plug in a negative 4, I get out a positive 4. So plugging in that negative 4 is going to give you the largest answer. On number 20, we need to write those two numbers using the same base. So I always look towards my smaller base, which is 2 in this case, and I ask myself, can I write the other number using that base? So if I have a 2, I would say, what power would I need to raise that 2 in order to get an 8? And that is going to be the third power. And you can use your calculator to help you go through those numbers if you need to. Once you get those bases the same, that is what it will let you set your exponents equal to each other. So now I can come back and I can say 3 equals x minus 2, and I can add 2 to both sides and say that x equals 5. For 21, we need to simplify those and write our answers without exponents. First thing I notice is that there's a negative exponent. To get rid of a negative exponent, you move it. So if it's in the numerator, you move it to the denominator like this one, which means sometimes you have to create your own fraction. So 3 to the third in the denominator, then you put your placeholder of 1 in the numerator. So 1 over 27 would be your answer. On B, if you wanted to fix that 5 to the negative second, put it in the numerator first, you can. I usually don't do that until all my bases are combined and together, so I would keep my base of 5. I would use my exponent rule of 5 plus negative 2, which is 5 to the first power, so the answer is just 5. On number 22, we're going to deal with a lot of negative exponents, and the first thing I notice on A is that the only thing wrong with that problem is this c to the negative fourth power. We need to shift that down, so I'm going to create my fraction. I'm going to put it in the bottom, but everything else stays where it is. So 3ab squared. On B, before I fix any kind of negative exponent, I'm going to combine everything that I can. So 4 times 2 is 8. A to the 3 plus negative 1 is 2. And then B times B to the fourth is B to the fifth. And then I don't even end up with any negative exponents that I have to deal with. On C, it's a power to a power, so I have to apply in that negative 2. So if I multiply my exponents, a to the negative 6, can't have that negative exponent, so I've got to create my top and bottom, my fraction. So I put a to the 6 in the denominator. I put a 1 on top. On D, I would go ahead and combine those first, so we get a to the negative third. Can't keep that negative 3, so move it down. 1 over a cubed. Couple of things going on with E. And the first thing I notice is that I've got 25 over 5, which I know reduces to 5. But I can also, if I'm looking, that x to the negative third, I can move it up, and the y to the negative second, I can move that up. So if I simplify 25 over 5 to 5, and I move the x cubed to the top and the y squared to the top, my answer is just going to be 5x cubed y squared. And then finally F, I'm going to go step by step. So we've got 24 divided by 6, which is 4. Then we have x, and if I subtract those exponents, be careful because it's going to be a double negative. 2 minus negative 4, which is 6. And then y to the negative 3 minus 1, which is negative 4. So we have to move that to the bottom. So our 4x to the 6th stays on top, and our y to the 4th goes to the bottom. On number 23, we definitely need to go step by step because there's several steps. So I see several exponents that I need to apply in. I'm going to multiply those exponents, so that's going to be r to the 8th, r to the 14th, or excuse me, s to the 14th. Let me go back, write an s. Then this middle term, I've got to apply in the negative 5 to the negative 2, the r and the s. So remember, when you have a negative 2, I would go ahead and put that in parentheses, negative 2 to the 5th, r to the 5th, s to the 5th. Anything to the 0 power is 1. So I would just mark that out. And then I have to apply in this 2 to the denominator, to the 4, the r cubed, and the s to the 5th. So we've got in the denominator 4 squared, r to the 6th, s to the 10th. Now I'm going to multiply on the top, but first I need to go ahead and evaluate that negative 2 to the 5th power. So that's going to be negative 32. Then I'm going to add my exponents on my variable, so that's r to the 13th, s to the 19th, divided by, so 4 squared is 16, and then r to the 6th, s to the 10th, so if we divide, that's negative 2, r to the 7th, s to the 9th. So the answer would be B. Number 24 says which expression represents the area with sides with those two side measures. So we are multiplying those together. So that's going to be 2 times 5 is 10. And then if I take my x's, I add their exponents, which is going to be 3. Y, 4 plus 4 is 8. And then z, 1 plus 3 is 4. So that would be C. And 25, the cube's edge is 2x cubed units. Determine the base area and the volume. So we have to remember that the base area is length times width, and the volume equals, and you can say this a couple different ways, length times width times height, or you can say that volume equals base area times height. So I'm going to do the length times width first. That's going to be 2x cubed times 2x cubed, which is 4x to the 6th. And then if we do the volume, if I use the formula with base area, volume equals, we already know the base area is 4x to the 6th. Then we can multiply it by the height, 2x cubed. So that's going to be 8x to the 9th power.
For number 26, this is just like some we did on the last page. We just have to subtract our variable, or subtract our exponent, since we are dividing like bases. So that's going to be a to the 1st, b to the negative 3rd, and then c to the negative 1st, and then take care of those negative exponents by moving them to the denominator. So it's going to be a over b cubed c, which is going to be D. For 27, evaluate and write the result in scientific notation. We're just going to do scientific notation in our calculator, exactly the way we see it. The most important thing is after you put in that negative 3, you arrow to the right so that you get out of that exponent. Then you close your parentheses, and then you can start with the second one. 3 times 10, caret 15, arrow to the right, close your parentheses. Mine gave it to me in scientific notation. I'm going to double check the mode. I'm actually in scientific notation, so I'm going to change it back because sometimes, see, that one was, the number's just too big. It's automatically going to give it to me in scientific notation. So 1.02, remember that E is just times 10 to the 13th power. Then in number 28, you could put that in your calculator if you wanted to. Before you did, you would probably need to put it in scientific notation. So I would go back to mode, arrow to the right, highlight the SCI. Then I could go back and put that in. But the most important thing is when you're counting, you have to stop at a number that's between 1 and I like to say 9.99. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gets me to 6.2, 5, 7, 9 times 10. Then I have to decide whether that 10 is a positive or negative, and since I started out with a really big number, it's going to be a positive 10. Number 29, in astronomy, the immense distance between celestial bodies is measured in light years, and it says the distance that light can travel in 1 year. 1 light year is approximately that really, really big number, miles. If a star is 5.2 light years from Earth, write an expression in scientific notation that correctly represents the number of miles the star is from Earth. So So I'm going to do that in my calculator, and that is multiplication. So if I want to know 5.2 light years, and I'm going to multiply that by how much a light year is. So that is 3440. And then I've got to put 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And press enter. So that's going to be 1.7888 times 10 to the 13th power. Starting with number 30, you can definitely use your answer choices to help you with these. And if it's a problem like 30, you need to put that in your calculator. So you would do 8 caret, do your alpha y equals so that you can make your fraction, and then do 5/3, press enter. And I need to go back out of scientific mode, go to normal. And then I didn't press enter on normal, so normal. And now I can press enter and see that that is 32. On number 31, we're not just evaluating, we are actually rewriting this as a radical. So we know we're going to have a radical with 13 underneath. Your denominator of your fraction tells you your index, that goes on the outside. The sixth goes on the inside, so the answer would be B. On 32, we need to use our exponent properties of power to a power. So I apply that in to the a to the 12th power. So 12 times 2/3 is going to be a to the, and that's really 24/3, which is just a to the 8th power. Same thing on number 33. This time we have to apply in this 1/3 to the 8 and the x to the 6. So that's going to be 8 to the 1/3 power. And then x to the 6 times 1/3 is going to be 2. I could cross out answer choices if I wanted to. That might be helpful. And then I have to pick between 2 and 8/3. So you might want to put 8 to the 1/3 power in your calculator. 8 caret alpha y equals 1/3. Press enter and you'll see that it is 2. So the answer is A. Lastly, we need to use our multiplication properties when it comes to exponents. That doesn't apply to our big numbers. 2 times 3 is 6. And then x to the, and 2/3 plus 5/3 is 7/3. So the answer is C. On number 35, we can use our calculator to sketch that function, and then we're going to find each of the following. So you go to y equals, and you're going to put it in exactly the way you see it. 2 parentheses, 3 caret x. Make sure you arrow to the right, press parentheses, and plus 1. If for some reason your graph is off, make sure that you hit zoom 6. I'm going to do that just in case. So I hit zoom 6 and it stays the same. One thing I like to do to find the y-intercept, if you hit this trace button, it's going to pop your cursor to the y-intercept. So our y-intercept is 0, 3. And then the next thing we want to look at is the domain. And if you look over here at our graph, it goes forever to the left, and I know it looks like it goes forever up, but it also goes a little bit to the right forever, so our domain is going to be all real numbers. Our range, you can actually use your equation up here to help us. This plus 1 is going to tell us what number that it approaches, but if you were to arrow to the left with that trace button, you're going to see that that number gets closer and closer to 1 but never actually touches it. That's called our asymptote. So that's going to be y equals 1. You can always, if you find your asymptote, your range is also going to be involving that number. So it's going to be y and something with 1. And you can tell that your graph is above 1. So it's going to be greater than, but make sure it's never touching 1. So make sure it's just greater than, not greater than or equal to. For our sketch, we can put a dot at 0, 3. If you want to put your asymptote, we do a dotted line. You might want to grab another point from your table. So I'm going to see if there's one on my graph. 1, 7 would be a good one. 1, 7. And then the next one is 2, 19. So 2 all the way up to 19. Let me see if I have one for -1 or -2. So we're just going to kind of estimate those, but you can sketch, hopefully better than that. And then the most important thing is that it never touches that asymptote. For number 36, we have Jen's investment was $4,500, has been losing its value at a rate of 2.5% each year. What will his investment be worth in 5 years? So we're going to use our equation. Y equals A, parentheses, 1. Since it's losing, I'm going to say minus R to the X. You could also say T power. Our initial values, 4,500. And then we have 1 minus, our rate is 2.5%, but make sure you change that to a decimal, 0.025. And then after 5 years, so our exponent would be 5. And we can plug this straight into our calculator. Parentheses, 1 minus 0.025 caret to the 5th power. So his investment would be worth, after 5 years, $3964.93. 37, we have a radioactive element's half-life is the time it takes for 1/2 of the element's quantity to decay. The half-life of plutonium is 241 is 14.4 years. The number of grams A of plutonium 241 left after T years can be modeled by the equation given, where P is the original amount of the element. Explain what the 0.5 represents in the equation. Well, since it is a half-life, that means it's losing half, so that is 50%. So a couple of ways we can think about this. If we had our 1 minus R, which we're used to, we could say 1 minus 0.5, and we would get our 0.5. Another way you could look at that is if you change 50% to a decimal, you would end up with 0.5. So either way you see it is fine. And then for B, it says write the equation of how much to find 0.2 gram sample remains after 72 years. So we just have to plug those in. Our P would be 0.2, and then we write our times 0.5, and then we have to put our 72 divided by 14.4 years, and we can put that straight in our calculator. 0.2 parentheses 0.5. Then I'm going to do my caret, and I'm going to use my alpha y equals to make that fraction, and do 72 over 14.4. And there would only be 0.00625 grams of that element left. So this was the equation, and then I actually accidentally went ahead and did C without reading the problem. Number 38, the workout gym sold 550 memberships in 14, and they give you the equation. 550 times 1.05 raised to the T power models the membership after T years. By what percent does membership change each year? So we know this has to do with this 1.05, but you have to remember to get 1.05, they added 1 plus 0.05. So this is our rate. So if you change 0.05 to a percent, that means they increased at 5% every year. So on 39A, if we look, notice that your X goes up by the same amount. You're adding 1 to each side. So we really just need to focus on the Y's. And if you look, it might be kind of hard to tell between the 1/4 and the 1/2. But if you look from 1 to 2, that looks like you're multiplying by 2. So if we go up and let's check 1/2 to 1. If you multiply 1/2 times 2, you get 1. And then same thing here. So if you multiply by 2, that is going to be an exponential graph. On B, we are on the left side on your X's, you're going up by 2 each one, so we don't have to worry about that. Then on this side, looks like we are plussing 3 here. Then we are plussing 6 here. So negative 7 plus 3 is negative 4. Negative 4 plus 6 is 2. Then we've got to do 2 plus 5 is, or 2 to get to 5 is plus 3. Oh, and I just realized I did something. So if I look over here on these x's, I should have taken the time to write these out because this is really a plus 2. This is a plus 4, but I got ahead of myself, and this is a plus 2. So just because they don't all go up by the same number doesn't mean we can't say it's linear just yet. We have to see if they reduce. So if I take 3 over 2, that can't reduce to 3 over 2. 6 over 4 is 3 over 2 when it's reduced, and then same thing for 3 over 2. So that is actually a linear graph. That one's kind of tricky. On C, we can start out doing the same thing. I'm actually going to check these this time. That's a plus 2. That is a plus 2. That is a plus 2. So now I don't have to worry about the x's. I've learned my lesson. This is a minus 6. This is a minus 2. And this is a plus 2. Now, if it doesn't add or subtract the same number, please make sure you double check that it doesn't go out to the second one. So this would be a plus 4. This would be a plus 4, because if the second row is the same, then that is quadratic. If the first row is the same, then it is linear. If the second row is the same, it's quadratic. And then finally, if we check this last one, that is going to be a plus 1. That is a plus 2. That is a plus 4. So the only way this would work is if I check the slope and they all reduce to the same thing. So this would be a plus 2. This is a plus 3. This is a plus 2. So if I check, 2 over 1 should equal 3 over 2, which I can already tell that doesn't work, should equal 2 over 4. So I checked those slopes and they don't match. So this would be none of those. And then on number 40, write the equation for the following geometric sequences. And you do need to make sure that you know this equation. A sub n equals a sub 1 times r to the n minus 1. That's your geometric sequence formula. Your rate is going to be whatever it's multiplied by, so that's going to be times 3. And your a sub 1 is going to be your first, I just realized that I missed the first one, but luckily it happens to be 3. So a sub n equals 2, since that's the first time. And then you have a 3 raised to the n minus 1. And then the second one, this one's a little bit more difficult. We may need to grab our calculator just to make sure. So in this case, I'm going to look at down here, and it looks like if I multiply by 2, I'm going to get to the next one. So I'm going to go ahead and come over here, and I'm going to use my alpha y equals. I'm going to say negative 3 over 8. Ooh, not like that though. Alpha y equals negative 3 over 8. And then I'm going to multiply it times 2. And that gives me negative 3/4, which is next, so I know that works. And then if I do times 2, I'm just double checking now. 3/4 times 2 is negative 3/2. So that is going to be my rate. So this one's going to be a sub n equals the first term, which is negative 3/8, parentheses 2 raised to the n minus 1. And if it just asks you for the equation, that's all it wants. Then we have what would the fifth term be of the geometric sequence. So this really means that n equals 5. So a sub 5, that's just a notation, is 2/5, parentheses 3 to the 5 minus 1. And I would just put that in my calculator. Alpha y equals 2 over 5, parentheses 3, and then raised to the So caret 5 minus 1, I can just put in a 4. And I end up with 162 over 5. The last one is the exact same way. We just have to plug in 26 for n. So a sub 26 equals 3/16. And then 2 to the 26 minus 1. And then same thing. I'm just going to grab this, and then I'm going to change my numbers. So I get 3 over 16. And that is a 2. And that exponent is going to be a 25. So that's going to be a big number, 629, 1456.